Welcome to another edition of Physics Talk. I'm your host, Dr. Groff. We are in class. We are voyaging through Newton's laws, the application of Newton's laws, and I thought it might help if you got a little bit more practice. So I invented this problem, which should strangely look familiar to you, um, reminiscent of maybe another problem that is part of your homework assignment. The names, the faces, the places have been changed, the numbers have been changed, but the similarity remains. Here's the situation. Two donkeys are towing a flying saucer as shown in the figure below. The sum of the forces Fa and Fb exerted on the flying saucer by the donkeys is parallel to the dashed lines. What that says is if you add Fa and Fb together, they're vectors. The resultant vector would point in the same direction as this dashed line points. You're given the magnitude of Fa, 4,000 newtons, and you're asked to find the magnitude of Fb and the magnitude of the sum, Fa plus Fb. All right, so you know the rules. Before you even start doing this problem, we need to define, all right, I like doing this. I'll call right the positive x direction, and I'll call up the positive y direction. Got to do that before you start. All right, well, there's some things that we can do right away. But these forces then, Fa will have an x component and a y component. Fb will have an x component and a y component. And since we're given the magnitude of Fa and the angle, this angle 20 degrees, we can go ahead and resolve Fa into its x and y components. So the x component of A is going to be pointing to the left, so it'll be negative. And since that side of the is opposite the angle given, the magnitude will be given by the sine function. And when you plug this in your calculator, I get minus 1,368 newtons, and Fa y equals, and the y component of A will be positive since it's pointing along that dashed line, and it'll be given by the cosine function. Since that side of that component is adjacent to the angle that's given. When you do this, you get 3,759 newtons. Okay, now let's turn our attention to Fb. Right? You know, this is the flavor of these problems. We have two-dimensional vectors, resolve them into their horizontal, vertical components, x and y components, and then operate in the two dimensions separately, and then bring everything back together in the end, if need be. Well, we can right away, all right, the problem says that the sum of the forces exerted on the flying saucer by the donkeys is parallel to the dashed line. So if the sum, change pointer colors here. Let's not use red, let's use a different color. Let's use cyan. The sum of these two forces is going to point along this dashed line right here, which means that the resultant vector Fa plus Fb, or another way of saying this mathematically, is that the net force in the x direction will be 0. This resultant vector has no x component. The net force in the x component is 0. So if we ask ourselves, well, what forces are in the x direction? We have, there'll be an x component of b, and there'll be an x component of x. Add them together, we get 0. Well, we just found what Fax is, so that means Fbx must be equal to 1,368 newtons. All right, well, now we're home free because now we have one of the components of B, and we're also given this angle that B makes with the dashed line. So the two remaining things to find here is the y component of B and B itself. Well, we can use our trig functions to find these two things. We know the x component of b. Well, we know that the tangent of this angle 50 degrees is equal to opposite over adjacent. Right? The side, the component of FB opposite the angle would be FBX. And the side, the component of FB that's adjacent to the angle is FBY. So FBY equals tan 50 degrees divided by algebra FBX divided by tan 50 degrees, which is going to equal 1,148 newtons. All right, and then FB is the hypotenuse. It's the hypotenuse of a triangle that's made by the components of FB, and we know that, well, there's several ways we can find this, but one way is that we know that the sine of angle 50 degrees will equal the component that's opposite the angle, which again is FBX, divided by the hypotenuse, FB. So FB will equal sine 50 degrees divided by algebra order. Okay, there we go. FBX divided by sine 50 degrees, which is equal to 1,786 newtons. Okay, we're almost finished. This is one of the things we're asked to find, the magnitude of B, 1,786 newtons. The other thing we're asked to find is the sum, FA plus FB. Well, we know that if we add the x components of these two vectors together, we get 0. If we add the y components together, we get 1,148 newtons plus 3,759 newtons equals 4,907 newtons. So the sum, using the Pythagorean theorem, FA plus FB will equal the square root of the x component squared plus the y component squared, which equals 4,907 newtons. Not surprising, the sum of just the y component, since there's no x component. So here are the answers to this problem. All right. I hope that, all right, so like I said, this problem should seem strangely reminiscent of a problem that you have in your homework, and hopefully that you struggled with that problem, and hopefully you got it without having to watch this video, but you know, or maybe you only got part of the way there. So hopefully this helps you to see the logical steps to follow to do this problem. Okay, well, that's all for a physics talk today. Have a good day.